Hello there, Mr. Wilson here again for another GCSE Further Maths explanation video. Now in previous videos I've talked about stationary points, differentiation, matrices, just to name a few. In this video I'm going to talk about triple simultaneous equations. Now, triple simultaneous equations is something that can come up on the normal GCSE maths, the higher tier. So if you are watching this for normal GCSE maths, then welcome. You are more than welcome to watch this video if you need support with that. But this is targeted mainly at students who are taking the GCSE Further Maths, in which triple simultaneous equations is a very important part of that scheme. So in this video I'm going to talk through some questions. I'm basically going to give you the insight into how my brain would process these questions, how I would figure out these questions, and insight into the do's and don'ts if I was sitting this question in the exam of what I would do. Now, if you haven't already, definitely subscribe and make sure that you are following along with all these videos. You're ashamed to miss out on any of them. But also, you know, if you've got any questions or things like that, please feel free to put them in the comments below. It's really interesting to see people's questions and thoughts of after watching these videos. So without further ado, let's have a go at these questions. And by the way, these questions are from Corbett Maths, so shout out to Corbett Maths for these wonderful questions. I would have written some, but you know, why reinvent the wheel? So shout out to Corbett Maths and for providing these questions and just coming up with some great resources in general. So solve the simultaneous equations. X minus y, x plus 3z is equal to 5, x plus y plus 6z is equal to 12, and 3x minus 2y plus 2z is equal to 10. Well, the first thing I would do if I was doing this question, I would label these equations. So I'm going to call this 1, this could be 2, and this could be 3. Now, to solve triple simultaneous equations, the basic idea is you want, in an ideal world, you want something that's just got like x's and y's in, right? And you want two of those, because if you had that and this was equal to something and this was equal to something, let's say, if you had two equations that have just x's and y's in, well, then you could just use what you would normally do for normal simultaneous equations, because you've got two equations with two variables and you would solve it normally. So basically we want to get to a point where we have that. We have two equations with just two variables in it. It doesn't matter if it's xy, xz or yz, but you want two equations with just two of the same variables in. So what I'm going to do is I'm going to select equation 1 and equation 2. And equation 1, just to rewrite it out, is this. Equation 2 is this. Now, you have to then decide which variable you are going to get rid of, because remember, we only want two variables in two equations. So you have to decide which one you're going to get rid of. Now, I'm going to get rid of y in this case. Now, again, there is no right or best way of doing this necessarily. You could eliminate x or z. There's no best way here. I'm just going to eliminate y. Now, to eliminate y, we've got a negative y and a positive y here. So I'm going to add these two equations together. So I'm going to do equation 1 plus equation 2, because that's going to allow me to do x plus x is 2x. Negative y plus y is 0, which was the whole point. That eliminates. 3z plus 6z is 9z. And 5 plus 7 is... 5 plus 12 is 17. I was mixing the words there. So we've got this new equation, 2x plus 9z is equal to 17. And I'm going to call this equation 4, because that's going to be useful later on. Now, if I can do pretty much the exact same thing and get a new equation with just x and z in, well, then I can just do what I would normally do for simultaneous equations, and I get my final answer. Just be really careful when you are performing this method that, you know, we're getting these terms right. If we're adding these terms together, we're adding them. We also add these numbers together as well. So now, in order to get another equation, you have to pick two different equations. So originally I picked 1 and 2, so I have to pick two different ones. So this time I'm going to pick, I don't know, 2 and 3. So equation 2 is x plus y plus 6z is equal to 12, and 3 is 3x minus 2y plus 2z is equal to 10. Now, in order for this method to work, you have to eliminate the same variable as what you did the first time. So because I eliminated y initially, I've got to eliminate y again. Now you'll notice that the number of y's are not the same here. So what am I going to do? Well, I'm going to multiply equation 2 by 2, because then that'll make the y's the same. And when you multiply an equation by 2, you've got to multiply everything by 2. So I get 2x plus 2y plus 12z is equal to 24. Well, now I have the same number of y's, so I'm going to add these two equations together, because negative 2y plus 2y is 0, and they will eliminate. So 3 plus 2, equation 3 plus 2 lots of equation 2, 3x plus 2x is 5x, negative 2y plus 2y is 0, that was the whole point, 2z plus 12z is 14z, 10 plus 24 is 34. So I get this new equation, 5x plus 14z is equal to 34, and I'm going to call this equation 5. So now I've got this equation here with just x and z in, and I've got this equation here with just x and z in. Well, I can just do what I would normally do for simultaneous equations, right? I can basically ignore everything else that I've done and just focus on, imagine I had a question which was just equation 4, 2x plus 9z is equal to 17, and equation 5, which is 5x plus 14z is equal to 34, and I would just solve those simultaneously. So I could basically forget everything else that I've done so far and just solve it simultaneously. Well, what I would do here is I would multiply this first equation by 5, because I'm going to eliminate the x's. So I'm going to do 5 lots of equation 4. That gives me 10x plus 45z is equal to 65. No. Yes? No. 85. No? 65. 85? 85. Why was that so tricky to work out? 85. And 2 lots of equation 5, that gives me 10x plus 28z is equal to 68. I would subtract these rather than add, because 10x take away 10x is 0. So I'm going to do 5 lots of equation 4, take away 2 lots of equation 5. 10x take away 10x is 0. 45z take away 28z is 17z. 85 take away 64, that's going to be 17. So z equals 1. Z is 1. Once you've worked out one of the values, now again, if you eliminated z initially and then y, you would be working out x right now. So it all depends on which one you're eliminating. But as soon as you've worked out one of the values, it is just about working backwards, substituting in to find the other ones. So because I know z is 1, well, I know that from equation 4 that 7x plus 9 lots of z, so plus 9, is equal to 17. So 7x is equal to 8. Is that going to be right? Yes? No? Yes? Oh, it's 2x. I can't even read my own handwriting. 2x is equal to 8. Get rid of that. So x must be 4. X is equal to 4. And then once I know both of those, I can go back to one of the original equations to work out what y is. So from the second equation, you can use any of them, it doesn't matter, you'll get the same answer. X is 4 plus y plus z, which is 1, so 6 lots of z is 6, is equal to 12. So y is equal to 2. So x is 4, y is 2, and z is 1. Now, once you get an answer like that, you should absolutely 100% sub back the values into a different equation to check your answer. So if I check with equation 1, equation 1 says that, well, x is 4, take away y, which is 2, plus z, which is 1, so 3 lots of it is 3. Well, 4 take away 2 is 2, plus 3 is equal to 5, and that is correct. And again, you could then check it in equation 3 just to be absolutely certain that that is the right answer, but that is how you get it. So essentially, Triple simultaneous equations is the same method for whatever equations you've got. What you are essentially trying to do here is find two equations with just two variables in, then just solve as you would normally do simultaneously to work out one of the values, then substitute back in. So at this point you're kind of working backwards, substituting back in to find the other values here. And that's what you would get. Now, it's very common for triple simultaneous equations to be a non-calculator question, but that is essentially how you would do this. Okay, I'll have a go at another question in this video, and hopefully this will elaborate more. But you'll see with another question, I will perform almost the exact same method, just with different numbers. So let's have a look at another question. So again, solve simultaneously. I'm not going to read them all out in this one, but I'm going to basically go through the same process. So I'm going to call this equation 1, this equation 2, and this is going to be equation 3. Now, in this one, I might eliminate the z's because we've got 5, 15, and 10. So I'm going to pick equation 1 and equation 2 again, and I'm going to do 3 lots of equation 1. So I'm going to get 6x plus 9y plus 15z is equal to 63, and equation 2, just to rewrite it out, is 3x plus 6y plus 15z is equal to 51. Okay, well, I'm going to subtract them because we've got the same number of z's, and by subtracting them we won't have any z's. So 3 lots of equation 1 subtract equation 2, 6x take away 3x is 3x, 9y take away 6y is 3y, 63 take away 51 is 12. So I get this new equation, 3x plus 3y is equal to 12, and I'm going to call this equation 4 because that's going to be super helpful later on. And then I just need to perform the same process but with 2 different equations. So I'm going to do, I'm going to take equation 1 and multiply it by 2, and I'm going to take equation 3. So we get 4x plus 6y plus 10z is equal to 42, and equation 3 is 5x plus 4y plus 10z is equal to 37. Now, to eliminate these, we would subtract again, because 10z take away 10z is 0. So 2 lots of equation 1 take away equation 3. 4x take away 5x is minus 1x, or minus x. 6y take away 4y is 2y. 10z take away 10z is 0, that was the whole point, and this must be equal to 5. So we get a new equation, minus x plus 2y is equal to 5, and I'm going to call this equation 5. So now I've got equation 4, which is 3x plus 3y is equal to 12, and equation 5, which is minus x plus 2y is equal to 5. If I multiply equation 5 by 3, so remember equation 4 is this, but if I multiply equation 5 by 3, I get minus 3x plus 6y is equal to 15. And then I would add these equations together to eliminate the x's, right? Because 3x plus negative 3x is 0. So equation 4 plus 3 lots of equation 5. 3x plus negative 3x is 0. 3y plus 6y is 9y. 12 plus 15 is 27. So y is equal to 3, because you divide by 9. So y is 3. Once I know that y is 3, it's then about just subbing back into, going backwards to sub back in. So equation 4 states that 3x plus 3 lots of y, well, y is 3, so this would be 9, is equal to 12. So 3x is equal to 3, x is equal to 1. So that would be the second solution, x is 1. And then once I know both of those, I can sub back into one of the originals to find z. Well, equation 1 says that 2 lots of x, which is 2, plus 3 lots of y, which is 9, plus 5z is equal to 21. So 11 plus 5z is equal to 21. 5z is equal to 10. Z is equal to 2. So z equals 2 is the final solution. And again, you would absolutely 100% sub all 3 values into another equation to check. because in some rare cases you can actually get three values that work for one equation but don't work for the other two, but they should work for all of them because we're solving simultaneously. So a quick check would tell you that for equation 2, 3 lots of x, which is 3, plus 6 lots of y, which is 50, not 54, 3 times 6, 18. It was because I thought it was 9. Plus 30, well, that's equal to 51, and that is correct. That's what it says it's equal to. And again, you could check with the third one if you wanted to be absolutely certain, but I'm pretty happy with that. So what you will have noticed there is that I've basically performed the exact same method. This is the thing about triple simultaneous equations, and actually simultaneous equations in general, really, is that the method behind it is the same. Which is why when I have students that have struggled with this in the past, it's just practice. It just has to be practice on these questions. That's by far the best way of learning this topic, because I can tell you right now all the mishaps that happen. For example, students get very confused because there's a lot of working out here. So it's important that you set out your working out in a way that is manageable. I wouldn't write this bit on the right. The only reason why I've written it on the right is because I can't fit it underneath. So I would write this underneath if I had the space, or I'd use extra paper. I would really make sure that I don't get lost in my working out. That tends to be one of the most common problems. Second problem I've seen is that students forget to multiply every single. So if they've said 2 times equation 1 or 3 times equation 1, they forget to multiply every single thing by 3, every single term, and the number on the right hand side. That's a common mistake. When they do the elimination, they forget to subtract every single term or add every single term. So, but the problem with simultaneous equations, especially triple simultaneous equations, is one small error early on causes like a snowball effect where the answer is so far off the correct answer, and it is really, really difficult to check. Unbelievably difficult to find that one tiny mistake. Like, as a teacher, I actually hate marking triple simultaneous equations because it's so difficult to find the mistake in the working out, because there's so much of it. It could be something as small as a sign error. I've seen where students have miswrote down a plus for a minus, and that can throw the answer off, but that is so difficult to spot. So what I would recommend when performing these questions is make sure you set out your work to the best of your ability. If you get an answer and it doesn't feel right, and you've checked your answer and it's not working, then you've got sort of 2 options. One, you redo the question from scratch, although I know that can be quite disheartening, especially when you put loads of time and effort into a question. Or you try and spot that mistake, but it is very, very difficult to spot a mistake in triple simultaneous equations because there is so much working out. Now, if you would like more videos on triple simultaneous equations, I'm more than happy to do it. But like I said, the best way to learn this topic in particular is just through practice. It's by going online, asking for or finding some triple simultaneous equations and just giving them a go. You know what I mean? You might make a few mistakes here and there, but the method is what matters. And I think the method, if you've got it nailed, it's just then about correcting those maybe tiny errors, mathematical errors that are happening. But the method is the key part here. If you can do the method and understand why it works, then that's the essential part here. And then those little, sign errors or multiplying errors will hopefully go once you've got the method absolutely nailed. So definitely go away, have a good practice. If you're still unsure, let me know in the comments below. But it's about having to go yourself and processing it yourself. I think that's really important in maths. Well, it's been an absolute joy to talk about further maths and the topics are on it, or normal maths if you're watching this as a normal maths student. If you stuck all the way to the end, well done. Not many people stick through 20 minutes of me talking, so thank you for that. But yeah, all I want to say is thank you so much for watching, and I hope you have a fantastic day.